Thank you very much. Thank you for inviting me here. Thank you to Micron, particularly, as we learned in that last speech, because you're helping to protect Jeeps from hacking. As some of you may know, the person who was hacked in that story that we just heard about was one of my most productive employees. So if Micron can keep him alive, we will have great stuff in Wired. So thank you very much for that. We have an amazing panel. One of the things I love about it is when you're a moderator, you often get nervous about people's titles. Last night I was doing a foreign policy event, and I couldn't remember right before the moment whether it's the deputy secretary or the assistant secretary. But what's good about this panel is that everybody is a CEO. Makes it simple, makes it great. So I'm going to introduce them all. Since they all have illustrious bios that could fill pages, I'm just going to give one number for each person, which is emblematic of one thing. So we have Lisa Su, CEO of AMD, and the number I want to give you is 1.87. That was the stock price when she became the CEO 4 years ago. It is now 33. We have Steve Mollenkopf, the CEO of Qualcomm. The number there is 46,000, which is the number of patents the man has. Welcome. We have Lip Bhutan, the CEO of Cadence, also runs Walden, and the number for him is 108, which is the number of companies he has invested in that have gone public. And we have our friend Sanjay, and the number for him is an interesting one. It's 1. And that is when I go to Davos every year, I meet with tons of people, and I write down all of my notes, heads of states, everything like that. And then at the end, I order them based on which conversation was the most interesting. And I was looking back at my notes, and Sanjay was number 1, because it was my favorite conversation in Davos of last year. So thank you very much. We're going to talk for a little bit. At the very end, we'll have 5 minutes of Q&A. Let's get going. Lisa, how are you?
I'm wonderful, thank you.
Great. So one of the reasons, as I understand it, that AMD went from 2 to 33 is that you came on board and you said, we're doing too much. We should do less. Let's focus here and not there. So now, as you look into the future, what are you going to focus on?
Well, first of all, I want to thank Sanjay for having me here. It's wonderful to have such a great partner. And look, I think he actually said very well what is so exciting about semiconductors. The fact is, our job is to make everybody's life better. I mean, that's what we do as an industry. And so from an AMD perspective, we're all about high-performance computing. How can we push the envelope on technology and performance? But whether you're talking about the data center or you're talking about the edge, every one of those applications requires more compute, more memory, more storage, more capability. And our job is to make that available to everyone. So.
Okay, but which one of those is most exciting to you right now?
It's all about high-performance computing for us.
So it's the data centers.
It is absolutely the data center. I mean, when you think about, the fact is, every one of us is generating so much data. And whether it's your business or your personal life or the environment and the infrastructure, and we don't actually even know what to do with all of that data. And computing, high-performance computing, really will help us analyze all that, ensure that we can make decisions on it, and frankly, just make our lives much more intuitive.
And is Sanjay correct to be very worried about the energy costs and to be very focused on ways to conserve energy in the data centers?
Absolutely. I think when we think about data centers, it's all about total cost of ownership. How do we ensure that whether you're talking about performance or power, that it's optimized for longevity. So yeah, power consumption is huge for us.
Lip-Bu, do you agree with that? Do you feel like data centers are where the most exciting action is going to be in the next 10 years?
Yeah, I think so. I think this is a very exciting time for semiconductor. You have 5 ways come together. You have a data center cloud, you have the 5G, and then very big AI machine learning, and industrial IoT, and also the autonomous driving.
Yeah.
So in fact, a lot of big system company and hyperscale guy all quietly building their own silicon team. And it's exciting. I mean, the innovation and the design activity is increasing substantially. And from Cadence design, we love it.
Okay, so everybody in this room knows that autonomous cars are coming to some degree, IoT is coming to some degree, 5G is coming to some degree. But a man who's invested in all of these companies knows more, certainly than I do, knows more than most of these. What is going faster than you expected right now?
I think it's all about data. And so it's an explosion of data. And then today, it's only 2% of the data being utilized or analyzed. And can you imagine how much impact going to be making? And that's why you see MIT putting a school of computing as a new way of computing using AI machine. I'm on the board of trustee at the Carnegie Mellon. They give degree undergrad on AI. And so that means how big the impact going to be. And my good friend Masa is going to put in a second fund and a focus on AI. So I think AI is going to be a big impact. And then it really changed the whole infrastructure requirement from storage, network, and memory, and across the network switch. And so to me, it's a new era of changes requirement to fit all this data-driven economy.
Let's talk about that for one more second. So it's going to change the whole network requirements. How specifically will it change the processor industry, right? So you're going to have much more data that you need to analyze. You're going to need to have much less data leakage. You're going to have to go through it more quickly. Like what exactly is going to be different in the AI era?
Yeah, I think the big difference is I call it domain-specific processing. So it's great to have CPU, GPU. I think over time it becomes depend on different workload. You different optimize for different processor. And so I think that's a new class of emerging, I call it the domain-specific processing that depend on different workload, and you create that optimization, either it's in the training or inference or any application, either it's in the autonomous driving, going to generate so much data, and in some way, it's really good for Micron. You're going to demand so much data and storage, and then how to get close to the data so that you don't have the latency that that you're facing. And of course, I think data center are going to be huge. The whole infrastructure all the way to the edge before the cloud, because some of the things may not, latency may not suitable for cloud. They want to have the edge closer to the, for example, the industrial automation, and you need to be close so that you can really drive productivity.
All right, Steve, let's talk about another thing that just came up, which is 5G. Obviously, will be a big part of all of this, and you will be a big part of 5G. When am I going to get it?
Well, I think, it's interesting. Everybody asks that question, except in China. They never ask the question. They actually talk about how there's probably going to be about 100,000 base stations deployed by the end of this calendar year, so 2.5 months from now, a little bit less than that, and they'll probably go up by an order of magnitude in the next year. And if you look at the rate at which 5G phones are selling in South Korea, you'll see that's actually above what they did for 4G. So there's tremendous, I would say, energy involved in kind of the rollouts of 5G. Also, if you look at the devices, everyone's portfolio above a certain price point are all 5G. So it's a tremendous amount of activity in the cellular space. But I think the bigger long-term impact to 5G will be outside of the cellular space, and it will essentially grab a lot of the themes that were talked about today, which essentially is more and more of the computing and the smarts and the storage move to where the data is generated. And there'll be a combination and sort of, I think, a more of a distributed computing architecture across the network. And I think that's a very, very good thing for a lot of the people that are on, or everybody here on this stage. But the one thing we know is that storage will be next to the computing element, whether it's doing work at the edge of the internet or whether it's in the high performance area in the in the data center. He's going to be in a pretty good spot either way, I think.
All right, well, let's stick on 5G for a little bit, and then let's try to poke some holes in the idea that Sanjay's going to have everything perfect from now on. On 5G, what is obviously we need a whole bunch of things to come together, right? We need the base stations, we need the modems, we need the processors, we need the apps. What is the area where we're most limited right now?
Really no area. I mean, if you think today, what you're just seeing is a worldwide ramp, very consistent with other ramps, with one exception. China's launching in the same calendar year as the rest of the world. Traditionally, in a generational change in cellular, China, which is a massive market, is launching, maybe 5 years later. This time it's not. And the reason is, I think people understand the impact not only to the cellular industry, but also to industrial policy. to having everything connected, and no one wants to be late.
Right.
Because you want to build scale, you want to build these business models that depend on N, and you essentially want to get there first. And so there's a tremendous amount of activity. I mean, you can just see that in what we're working on. I think TSMC's guidance, for example, and some of the commentary was consistent with that. There's a tremendous amount of activity trying to figure out how do we get this stuff deployed as quickly as possible.
So, Sanjay, when you look ahead to this conference next year, where everybody will attend again, which devices will be running 5G, and how will Micron be deployed in them?
I think 5G is a huge opportunity for Micron. And it's not only about smartphones, it is absolutely about machine-to-machine learning, which 5G will accelerate. And just imagine billions of IoT devices that will be creating tremendous amount of data. Lip-Bu just said that only 2% of the data created gets analyzed. As more data gets created, as you bring more memory and storage to the edge and solves some of these problems, I think great opportunity to draw insights. And I think 5G will be a major driver of growth. I mean, just look at Mobile World Congress. In February of 2019, 5G phones that were announced there were phones with 12 gigabyte of DRAM, 8 gigabyte of DRAM. It used to be like 4 or 5 gigabytes of DRAM. So it will drive higher average usage of DRAM content. And of course, 5G is going to let you download your 4K movies in seconds on 5G, right? So more storage. At Mobile World Congress, a terabyte flash phone was announced as well. So we look at 5G as a tremendous growth opportunity for data, for memory and storage solutions, and we think it will really drive this across industries, across consumer devices for next many years to come. It will be a tremendous growth driver for not just memory and storage, I believe, for the entire semiconductor industry.
Well, let me ask, for anybody on the panel, tell me something that we'll be able to do in 5G that I haven't thought about. Tell me something that, with 4G, a whole new system of things we do came about. What will happen with 5G that surprises me?
Can I tell you one thing? I think the question itself undercalls what actually happens in these transitions. So, for example, everyone asks the question, give me the killer app. Well, the killer app is you get these tremendous speed improvements, you get tremendous latency reduction, and more importantly, you get about 1/30 of the cost per bit. So essentially what you get is tremendous business model evolution or experimentation because you got this new basically capability in the network. And if you looked at the 4G transition, no one would have guessed the amount of, I would say, new economy companies that were created. And I think trying to guess it is not really the right thing. What you find, though, is that every major industrial company and is basically trying to figure out, how do I deal with the amount of data that comes off my stuff wirelessly, and then how do I make my business even stronger as a result? Everybody on the stage benefits from that. And so when I look at it and I say, look, the whole goal is, how do you get this technology out at scale, give them the computing architectures that are invariably going to change, and get the experimentation to occur? Because no one thought that people were going to be able to create what they've created, even with the first generation of cellular. Now the cellular roadmap is disrupting basically every other industry. And I think the winners and losers are hundreds of billions of dollars companies that have yet to exist. And it's going to be pretty exciting.
So your position at Qualcomm is that actually it's kind of a fool's errand to try to predict what will happen. Something amazing will happen, but somebody else can do that. If we get the infrastructure right, we will just let it happen and that will be good.
Yeah, and I would say, to tie it to what you've heard today, is create the necessary conditions for there to be a lot of innovation on top of the fundamental technology. And then what everybody sees is they say, hey, look, the computing architecture is going to change. So how do we create these different type of computing architectures so that people can take advantage of this new capability of data being moving around? And that is what really drives. It is the industry that is yet to exist that I think drives the most value for the Valley and people. And so that's I think we're in a really a time period where that sort of the intensity of that is going to increase, and I think it's a great opportunity.
So what are the interesting architecture questions that are being answered right now, and the decisions were being made about how this technology is deployed that will, when we look back 5 years from now, we'll say, oh, that was a good choice that we made in 2019, or oh, that was a bad choice we made in 2020?
Well, maybe I'll just make one comment. I think the important thing, and I think you've heard it throughout this morning, is that the architectures are going to be different.
Yep.
There is no one-size-fits-all architecture. They're going to be quite heterogeneous, so you're going to need everything. You're going to need, CPUs, GPUs, FPGAs, ASICs, memory, and then the interconnection and the ecosystem has to come together. Mm-hmm. So the idea that one company can provide everything in that ecosystem probably is not going to happen. But it's really important how we connect those pieces as efficiently as possible. And those decisions are being made every day. I think by certainly our companies, but by the entire industry.
You guys are doing a good job connecting today.
I think distributed security is very important, and I would say almost trust would be the right thing, because what's going to happen is that the industries that are disrupted by these technologies are kind of serious industries. Autonomous driving changes logistics and transportation. Yep. The ability to connect, a lot of things, people's industrial manufacturing capability was mentioned today. So the ability to do that securely and to handle security from the beginning and not put it in at the end, kind of at the architectural layer, is a very important, I would think, avenue or sort of vector of innovation that you'll see.
And in some way, I think the 5G, it really depends on the workload. And then it will drive some of the different architecture. Like, for example, I strongly believe the whole industrial IoT is going to be huge. And I'm on the board of Schneider Electric. They were #1 in energy management and also in the #4 in industrial automation. You just can't imagine how much data they have in terms of controller that they collect and then store. And how do you apply that? There's a sense of urgency because of 5G. All these industrial players, they're starting to become very worried about being obsolete. So they really want to embrace AI. And then the other part is the security. All this data is so critical. And then how do you connect and then securely and protect that? So I think, all in all, I just give you one example. So I think it really depends on what workload. And also, if a data center, there's more tolerant for power, even though maybe power is still a big issue, and they consume so much. But for the industrial IoT, you have to be ultra low power. Mm-hmm. And then in some way, you have to self-sufficiently collect the data and wake up and send a message, the data that needed, and then go to sleep so that you can preserve the data.
Two of the things you just mentioned, one, a fear of industries that they're going to be disrupted, and two, the need for security, sometimes can be opposed to each other, because when you're afraid you're going to be disrupted, you act recklessly sometimes or very quickly. How do you make it so that companies that are afraid of being disrupted still prioritize security as they move to 5G?
Yeah, it's a good question. I think all different companies have different priorities. Mm-hmm. And so I think it's #1 is they want to protect the customer and provide better service. So it's moving more and more into the software defined and using software to changing the business model that Steve talked about. And then because some of this new 5G, that the bandwidth, the latency, that the speed that you can have, it creates a lot of new business model. And then you may have to change the way you service your customer and how you price it. Yeah. And so that's fascinating. Besides just the architecture design to be ahead of the curve, but the other part is how do you change your business model so that you can continue to excel or survive in some way.
Mm-hmm. So for Micron, in the past, it was mainly about producing memory components, right? But we are definitely, as we discussed this morning, addressing opportunities for high-value solutions, and one of them certainly is, as we introduced our Untitled Security platform, right? Putting in certain elements for certain applications, features related to security, building it into the memory as well, so that we enable platforms that can provide greater data security. So these are the kind of things we are definitely trying to take. Go from just memory and storage to really differentiated opportunities and solutions.
So was that a hard decision for Micron? When I was watching you say that on stage and you showed the chart getting higher and here are all the new things you were doing, I was thinking, wow, that's possibility of mission creep there. That's tough stuff to do. I bet you there's some people in the company who said, don't do that. Tell me about those conversations.
I think for us, it is natural.
Yeah.
We do have to engage with our customers as memory is becoming more and more relevant for them, as it is becoming more essential for them. We do have to expand our capabilities into understanding systems and software so that we can really understand how best to optimize the memory for their environment. So without that, especially as hardware is becoming increasingly essential, memory is playing a greater role, heart of all the future technologies. You have to understand what the customer is doing. So for us, I think it's an imperative that we start understanding and start increasing our capabilities in these areas. At the end of the day, customers will deploy those solutions. For us, it is more about exploring the possibilities and really defining our innovation agenda of the future.
And back to one of the things that we've been talking about and that Steve mentioned a minute ago, how do you build security in from the very beginning as you develop memory? Like, what are the architectural choices that you make now, the new architectural choices that you make?
For us, it really is working with the customers leading customers to understand what features they need, and then that's how we implement it. We are not trying to invent something that's not going to get utilized or commercialized later. So that's why deeper engagement with the customer for us is important.
Lisa, is this the way you think about it too?
Yeah, absolutely. For us, we have to design security from the ground up. It has to be part of the basic architecture, and I think all of us understand the importance of that trust element. So it is something that we really think about as a foundational element of the architecture, and then working with our partners, making sure that as data moves back and forth, that it stays secure.
Okay. Lip-Bu, I read an interview while I was preparing for this that you did for the Carnegie Mellon Alumni Magazine when you joined the board, and one of the things you said is that you want the smartest minds and the smartest graduate students to go into the semiconductor industry instead of going into ad tech or working for the platform companies. And my question is, we all spent some of yesterday watching Mark Zuckerberg get hammered in Congress. Given all the troubles of the platform companies, are you actually seeing a migration to the semiconductor industry? Is there any difference from 5 years ago, or is it the same?
Yeah, it's a challenge because for us, we are competing with Google and Facebook to get also talent, and especially the software engineer for Cadence. And it's not easy. Clearly, it's very important to get the mind share of the professor. I call it the impactful professors, because their students usually depend and recommend by the professor. And when I heard that semiconductor is a sunset industry, it really troubled me. And that perception.
They call it mature.
That's right, mature rather than
like
sunset.
mature is a bad thing. So.
Right, and to be candid with you, there's so much innovation needed, either from the 5G or memory, and there's so much, this AI or these 5 waves of changes, and there's so much innovation and so much cool stuff we can do. And so we decided, to do a very active university programs. So we reach out to all the key professors that we really want to have and get their mind share. And so in some way, we try to tap on all their PhD students or the undergrad students. And then some of the professors tell me that it's already too late. You have to start from the high school. And so we had to think a little bit ahead of time to get more involved, and from all the leading customer and our partner like Steve and Sanjay and Lisa, we had to do a campaign to all these universities that, hey, still a lot of innovation needed, and you can do a lot of cool stuff and work with us and then join us.
Do any of you feel that there's been a change in the way that people think of the semiconductor industry over the last couple of years as oh my God, so exciting, or about the same?
What I would add here is that, certainly Micron too, very much engaged promoting STEM at high school and middle school level, as well as certainly supporting universities and deepening our engagement with universities, and really trying to show to the students in the universities that how cool memory is. It is really cool. I've been passionate about this industry for 40 years, trying to inspire them with that passion. So we definitely are investing in the university ecosystem. But also what's important is that talent today is everywhere in the globe. And I think you have to go where the talent is. I mean, latest example for us is that Micron was not in India, and we have now expanded our capabilities in India, just opened a center there in India. And I think it's wonderful to see how, whether it's in Japan, or it's in Taiwan, or in Singapore, Europe, Germany, Italy, India, US, how engineers can work together. And I think this is what we are leveraging, the global talent pool in terms of attracting top talent. And then, of course, we have to make sure we continue to invest in developing talent that we have and retaining that talent so that the new skills that are needed, as advances take place in the requirements of the technology, our pool of talent can meet those requirements as well. So these are major focus areas for us in terms of making sure that in this highly competitive environment for talent, we are focused on making sure we are constantly taking our talent to the next level, as well as expanding our talent pool.
And when you think about, as somebody who spends a lot of his day thinking about AI and where it's going, how do you think about the way the jobs that people will do at Micron will change, and how to prepare your employees for work 10 years down the line where AI will be doing a certain portion of what they do right now?
Great question. And it is something that I believe all CEOs should always be worrying about, because there is no question that this wave of AI is starting to happen, is coming, and it will absolutely change jobs. I heard someone say that some jobs will be lost, some jobs will be gained, and some jobs will be changed. And that's why it's important for us, and that's why I mentioned, important to always look at opportunities to develop your pool of talent, understand how the shift will take place and the skill requirements for the future. This is still very early innings for us. I mean, of course, things that are happening, our manufacturing environment are changing some of the requirements from our production workforce, but AI is being deployed in actually all. Big data analytics and predictive intelligence is being deployed in all functions at Micron. Still in the early days, but this is one thing that I do worry about, that how to continue to focus on this area. Would love to hear thoughts from our panelists.
All CEOs should be worried about it all the time. We got 4 CEOs, 4 people who should be worried about it right now.
We look at it, and granted, we don't have a manufacturing workforce. We look at it as AI can help us make better chips. And at the end of the day, if everybody moves up the value chain a little bit, and it helps us, get time to market, shorter, that's goodness for everyone. So it's about figuring out how to use AI most productively. And Lip-Bu does a lot in the tools for us, and we do a lot in our own algorithms to try to get that more capable.
One encouragement is on the ventures capital investment side.
Yeah.
5 years ago, I was so worried that it's the declining and all the consolidation happening. And good news is it declined to almost investment is down to less than $2 billion a year. But it's really encouraging, and Steve may also support that. And right now, we're starting to see the turn to almost $2 to $3 billion. And so far, year to date, it's almost $1.8 billion investing. And so the trend is really exciting about this 5G and then the AI machine learning, that people get excited. I used to be on the VC, my brother and sister, none of them want to invest in semiconductors, so I had to kind of heavy lifting on that. But now the VC guys are starting to follow me and starting to become hot again. So I'm kind of excited about this whole vibrancy of the semiconductor industry.
Given the way all of your companies have performed, I wish someone had told me 7 years ago to invest in all of you. Steve, do you want to add to this?
Yeah, so I think for us, it's very similar to what Lisa said. It's a tool that we use that a skilled, trained person in the art can use to make their stuff or make themselves more efficient. I don't see it as something that replaces a person. It's just another thing in the toolbox. Because basically, AI is this thing that lets you do stuff when you're thinking about something else. That's kind of the way to think about it, right? And a lot of what we want people to be working on are things that don't exist today. That's really kind of what you're trying to do with innovation. but you can use it as a tool to help you optimize something that you would have spent a lot of time. So what we did, if you look at it, what we did was we basically added another skill set and another tool, just like when we had to add GPUs, and we had to have CPUs, and we had to have DSPs, and you got to have all these specialized processes. That's basically what it meant for us to have AI. It's a tremendous driver, however, of architectural change and what you might do in terms to implement, a network, for example, in a mobile device is very different than the way you might implement it in the data center, and there's a whole range of things in between. And that's where I think you tend to see a lot of the activity, which is what's the machine look like? What does the implementation of the network look like?
And what about the design process? When you think about, say, a modem 2 generations from now, how will the way its design is drawn up be different from the way it's drawn up now?
Well, at a very high level, sometimes when you do optimization, you can optimize in a different way than the traditional way that we did it. And your data that you have on the history of all of your test cases and all the field data you see, you can basically sort through that much more quickly than you could before. But the structure and the way in which we pull together modem architecture, for example, I don't think that's going to be replaced by some big optimizer. And in fact, if people wanted to do that, I would fund competitors to do that because I think that actually is going to spend a lot of time spinning their wheels. But I think it is a great skill set, but it is not the thing that changes the entire industry, particularly in the technology world, I think.
So I just want to share that on the memory side, for example, a lot of research is needed for new materials to be deployed in future memory devices. And using big data analytics and some of the predictive capabilities that AI provides really enables our engineers to use the AI engines to really even make breakthroughs at such complex level as material research, and tremendous opportunity. I mean, some of the things I talked about in our manufacturing, I mean, that, as an engineer, I know what it takes to drive every 0.1% of yield. To drive a 10% increase in output or 25% acceleration time to yield, humans can't do it alone. I mean, humans and AI is really tremendous capability, so very exciting opportunities.
We're gonna move to audience Q&A for the last 5 minutes. Priority will be given to anybody asking a question with an AI assistant, since humans plus AI is where it's at. So please raise your hand, and please try to stick to the topics that we have been discussing. I'm going to right over here on my left.
Hey, Mitch Steves from RBC. I wanted to, besides Lip-Bu creating his new high school in the future, I wanted to focus on one quick question, which is just the convergence of kind of software tools and hardware. So I guess more on the EDA side. So what we're seeing now is we're seeing like systems companies essentially create chips and software platforms on there. So where do you guys think you're going to see software and hardware converge the most? I know that EDA, for example, is working closer with semi-cap equipment, but just since we have all these different people on the stage here, where do you guys see software and hardware kind of coming together the fastest over the next 5 years?
Yeah, maybe I can take on this one.
Please.
So clearly, the AI, we use that at Cadence to drive the performance, power, and area and runtime. We see almost across the board multiple different product EDA tool that we see 12-15% improvement in terms of the time to market, runtime, and also PPA and runtime. And so all in all, I think, and also on the software and hardware, we have the Palladium Z1. Now we have the X1 Protium for the regression and software development can be much faster, and so that can help the customer design more effectively. And all of them are my customer. They really, we try to bring them the best solution, help them to drive the productivity and also the design, efficiency, and that we continue to, innovate on that.
Okay, great. Question in the middle, right there. Woman in the middle, in the green.
Hi, good morning. My name's Jasmine Shi. I'm with 808 Ventures. And my question to you is that within the quantum computing arriving, with the AI changing, how does your company changing to make that shift? So I just see that as the next generation computing. How are you guys preparing for it?
Great.
Maybe I start that. First of all, I think quantum computing is much closer to us than people thought. And I have been looking at a lot. And some of them using a superconducting approach. But two of them that I like a lot, they're using a little bit different approach. One is a trapped ion approach. The other one is using silicon photonics. And then at the end of the day is what application you try to drive. And back to the, and working with the customer closely. So far, I see pharmaceutical. I see some of these different vertical. There's a few become more clearer to me that they can use quantum computing plus the AI to drive some of the more efficient result that you want to get. So that's at least from my point of view. And then from EDS side, we don't see that yet, but we are curious to find out. Maybe Steve or some other panelists may have some comment here.
Yeah, it probably has less impact on our business. It's just because of where we are. We're trying to figure out how to get high performance and AI working with the least power consumption kind of at the edge of the internet. I think the quantum is really going to solve bigger problems sort of across bigger data sets than what we see. So it's probably less impacting our business.
I think for us, it's just very, very early research exploration that is happening in the ecosystem, and we keeping tabs on it. We never want to be left behind with any major innovation. So at this point, engaging in some experimentation, exploration with, customers that are potentially looking at this. But I think it is, personally, I think it is several years away.
Okay, we have time for one more question. Gentleman in blue.
Thank you. It's great that you guys have been fighting the battles of improving technology. But over the last few years, somebody's throwing curveballs at you by creating trade wars and international barriers of trade. And I'm wondering if you could give us some examples of how those trade wars, are impacting your business.
All right, we have 1 minute left. Who wants to take on one of the great questions in geopolitics?
Well, I think the host should definitely answer that question, right, Sanjay?
So, we have talked openly about it in our earnings call that, of course, some of the US-China trade issues are definitely impacting, some of the business in China, and Micron has talked about it in our public statements in this regard. So we do hope that these issues will get resolved and the businesses in the two countries will be able to engage in business freely and leverage the benefit of innovation across all of the humanities in all the countries. Of course, while following the principles of fair trade, level playing field, respect for intellectual property. So it does impact our industry, but we are very well diversified as well, and we continue to address those opportunities on a global scale.
We're out of time. Thank you so much for this fantastic panel. I learned a ton. I hope everybody else did too. Thank you so much.